Okay, so this evening we are going to talk about a data structure called a set, Python sets. So Python sets, as we are going to see, they work like lists, they work like tuples because they hold a bunch of information. Okay, so let's go into what our plans for the day. So the first thing we're going to do is we're going to see how to create a set using curly brackets, and as we're going to find out, we make sets using these curly brackets. So you need a pair of these curly brackets to make a set, or you can make a set using a function called set. That's what we're going to do. So we'll have to create some sets. Okay. The next thing we have to do is check membership to a set. You want to find out if something is actually in a set. These sets we are talking about, these are the same sets you do in mathematics. Okay? Is that clear? These are the same sets you do in mathematics where you do intersection, union, all those things. That particular set. Okay? That stuff. How you keep information in a set like that. That's what we are doing here. So we're going to see how to get the length of a set. We're going to see how to add items to a set. You're going to see how to remove items from a set. We're going to see how to empty a set. You're going to see how to copy a set. We're going to see how to delete a set. We're going to see how to obtain an intersection of two sets, a union of two sets, and also the difference of two sets. That's what we're going to do. Now, like everything else we've looked at, a set is a collection of items. The difference is, with a set, our items in a set are not ordered, and sets don't have indices. There is no position. Okay? First of all, the idea of position we've been talking about, first item, last item, second item, third item, fourth item, that idea does not exist with a set. Is that clear?
Yes.
The idea of position, say this is a first item, this is a second item, this is a third item, last item, that idea does not exist. What that means is you cannot use an index to access items in a set. Okay? Then there's also this idea, unordered. When you create a set and you put your items in a set, and how Python is going to display them, they'll be different, as you are going to see very shortly. Okay. So, like we said, for you to create a set, you can create a set using a pair of curly brackets, and that's what we're going to do. So, I create a set called planets, and in this set planets, I have Mercury, I've got Venus, I've got Earth, I've got Mars, I've got Jupiter, I've got Saturn, Uranus, Neptune, Pluto. So I have got items in this set, and I use curly brackets. So we just want to say, when you use curly brackets, then you've got items in this thing, you end up with a set. Python considers to be this a set, like that, planets. Then we check the data type of planets. Python tells us, say, what we have created is actually something called a set. However, because of the way I've created this set, you notice that each item appears once in a set. In this particular one, Mercury appears once, Venus appears once, Earth appears once, Mars appears once, Jupiter appears once, Saturn appears once, Uranus appears once, Pluto appears once, Neptune appears once. This set which I've created is hiding something which you're going to become aware of, and that is how many times an item can exist in a set. In a set, an item can only exist once. However, in a list or in a tuple, an item can exist many times. Is that clear?
Yes.
In a set, an item can only exist once. Each item is only allowed to appear once in a set. That is the biggest difference between a set and the lists and the tuples we've looked at. In a set, an item can only appear once. We will see that very shortly. So I print planets. There. Okay. I create another set. I try to create another set. Now, in this set which I'm trying to create, called provinces, you will clearly notice that these are Zambian provinces. You've got Eastern, you've got Mchinga, you've got Northern, you've got Luapula, you've got Central, Copperbelt, Lusaka, Northwestern, Southern, Western. It appears as if in this particular set, Zambia seems to have more provinces than it actually has. The reason why it appears like we have more provinces in this case, when I'm trying to create this case, is because I have deliberately duplicated some items. Some items appear more than once. For example, you've got Copperbelt here. You also have got Copperbelt. You have seen here Copperbelt highlighted, here Copperbelt highlighted, there Copperbelt highlighted. Copperbelt appears at least 3 times. You have Mchinga here, Mchinga here, Mchinga here, Mchinga there, Mchinga here. Mchinga appears 4 times. What else? Central province, Central appears 3 times. Eastern appears twice. Northern appears 1, 2, 3, 4, 5 times. Can you see this?
Yes.
That there is actually duplication in this thing I'm trying to create, this set I'm trying to create. Items appear more than once. The reason why I did this is so that I can show you to say, no matter how many times when you're creating a set, an item appears, it is only allowed to appear once. Okay. So, I need to change something here. That's supposed to be province. Provinces. So, there. Provinces does run. Then we check the data type of provinces. Okay, it's a set. What does it look like when you print it? This is what it looks like. This is what we have. You have Mchinga appearing only once, Southern, Eastern, Western, Northern, Central, Western, Copperbelt, Lusaka, Luapula. Have you seen this? That each item now only appears once. Hello?
Yes.
Okay.
Quite interesting.
Yeah, so each item now only appears once. The other thing is the order in which they appear. This is how I started. I started with Eastern, Mchinga, Northern, Luapula. Python decided, okay, it's going to start with Mchinga. When I started with Eastern, then after that, it goes to Southern. When my second item was Mchinga, like that. Okay? So Python kind of like does its own thing when it comes to sets. It decides on how things are going to be, every time you print a set, how things are going to be displayed. You don't have any control over where each item is. So when it comes to a set, apart from the fact that items only appear once, you have no control over which item is going to be the first item is going to be the second item, is going to be the third item, is going to be the last item, because the idea of position with sets does not exist. Is that clear?
Yes, it is.
Brian,
Is.
are we
Yes,
clear?
it is.
Are we? Is the distinction clear?
Yes.
The distinction between a set, between a tuple, and a list. They are very similar to each other, but they've got different properties and different behaviors. Okay, so we have created two sets. We have created planets. We have also created provinces using curly brackets. You can also create a set in a different way. You can create a set from a list. Like in this case, creating a set from a list. But as you create a set from a list, for you to create a set from a list, you need to use a function called set. Okay, so here, as you will notice, again, I create a list called SADC members, and you've got Zimbabwe, you've got Tanzania, Zambia, Mozambique, Angola. Again, deliberately, as you can see, Zambia here. Zambia is appearing. Zambia there, 1, 2, 3, 4, 5. Zambia is appearing 5 times. It's not that you've got 5 Zambias in SADC. No, this is deliberate. I did this. I duplicated this deliberately so that I can show you what happens when you try to create an item, a set from a list. A list accepts duplication. Okay, a list has got no problem with duplication. A tuple has got no problem with duplication. But when it comes to a set, each item has to appear only once. Is that clear?
Yes.
Yes.
Okay, so we run that. SADC members. We get the data type of SADC members. List, that's a list. Then we print out the list SADC members. There we are. Zimbabwe, Tanzania, Zambia, Mozambique, Angola, Zambia, Botswana, Malawi, Lesotho, Zambia, Eswatini, Congo DR, South Africa, Zambia, Madagascar, Mauritius, Zambia, Namibia, Seychelles. So those are the countries which belong to SADC. Okay. Then, for us to create a list, so for us to create a set out of this list, we use a function called set. This function called set, we give it the list SADC members. Then the result of whatever it's going to do, we want to store that result in SADC, a set called SADC. So we run that. So in this case, we are creating a set from a list. Okay, we are creating a set from a list. So you can move from having a list then to a set like that. Then if you check the data type of SADC, now we are told SADC is a set. If you print out SADC, here, this is what you get. You have Zambia first, Namibia, Mozambique, Botswana, Malawi, Eswatini, Congo, Madagascar, Seychelles, Lesotho, Zimbabwe, Mauritius, South Africa, Angola. Angola is last. South Africa. There is no order here. These items are not arranged alphabetically. There is no order. Can you see that?
Yes.
There is no order in a set. You don't determine where Zambia is going to be. If you look at our list, Zambia is number 3 somewhere in the list. Zimbabwe is number 2, is number 1. Tanzania is number 2. If you come to the set you've created, Zambia is number 1, followed by actually is the first thing which appears, first item. Then Namibia is the second item. Mozambique is the third, like that. There is absolutely no order, and the idea of position doesn't exist, as we're going to see. So order is not there. You can also create a set. So this is how you create a set from a tuple, from a list. You have to create a list, then you give your list to the set function, then the result of whatever of this operation, conversion, you store it in a variable, and that's going to be a set. You can also create your set from a tuple. Now in this case, I have a tuple I'm going to create. These are COMESA countries. And you've got Burundi, you've got Comoros, you've got Zambia, Congo, then Congo DR, Djibouti, Egypt. Again, Zambia appears there. So Zambia is appearing twice. Then Eritrea, Ethiopia, Kenya, Libya, Madagascar, Malawi, Mauritius, Rwanda, Zambia again, Seychelles, Sudan, Eswatini, Uganda, Zambia again, Zimbabwe. So we have Zambia appearing multiple times. 1, 2, 3, 4. 4 times to be precise in this tuple. For a tuple, if an item appears multiple times, there is no problem. Okay? But with a set, the requirement is that each item should appear only once. So there are COMESA countries, members. We check the type of COMESA members. Yeah, it's a tuple. Then we print out COMESA members. Here they are. Burundi, Comoros, the way we entered them, Zambia, like that, all the way up to the end. There are about 20 of them, actual COMESA countries. If you create a set out of these, say COMESA members, then this is a tuple, COMESA members. It's a tuple, as you can see from here. We give this tuple to the function set. Then the result of this operation, we store it in a variable called COMESA. If we do that, then we check the data type of COMESA. Now COMESA is a set. If we print COMESA, this is what we get. It starts with Kenya. When we started with Burundi in the list, followed by Comoros. Python starts with Kenya, followed by Zambia, Malawi, Congo DR, Sudan, Eritrea, Comoros, Ethiopia, Libya, Madagascar, Seychelles, Eswatini, Rwanda, Uganda, Zimbabwe, Burundi, Djibouti, Mauritius, Egypt. The Zambia, which appeared 4 times, only appears once. Is this clear?
Yes, it is.
Yes.
So in a set, each item is only allowed to appear once. Then 2, there is no order to which the items are appearing. The items cannot be arranged alphabetically or anyway, there is no order. The other thing which we are going to look at now is something called position. The idea of position in a set does not exist because sets don't have indices. Is that clear?
Yes.
Yeah, so let's see if we can access the first item of the set planet. Remember we created a set called planet? Let's try to see if we can access the first item of the set planet. So we run that. Can we access an item in a planet, in a set? Here. Python brings out the red pen saying, no, we can't do this. Okay? Then what's the problem? Here's a type error. Set object does not support indexing. There is an explanation why you can't do that. Because sets don't have indices. If sets don't have indices, then indices meaning they don't have positions, then you can't talk about first item, you can't talk about last item, you can't talk about third item like that. Is this clear?
Yes.
We try to access the last item in the set provinces. We know how to access the last item in the thing using index. Again, same problem. Python says, no, this is not allowed. Okay? You try to do a slice. Try to get a slice of items. You're not allowed to do that. Say, well, this is not, you can't do a slice. Is that clear? So with a set, you cannot index, you cannot slice. With a list, you can index, you can slice, you can subset. With a tuple, you can index, you can slice. With a set, those operations are not allowed. Is that clear?
Yes.
Yeah.
Okay, that's good. Checking. So how can you check for membership? Yes. You can check if an item is actually in a set. For example, I can check if Earth is in planets. I can do that using the in keyword. We have seen this one before. In. Earth in planets, true. Checking if Angola is a member of SADC. Angola in SADC, true. Angola in COMESA, false. Okay, so it's possible for you, as much as you cannot access items in a set. If you have a very large set, you can still try to find out if a particular item is in that set using the in keyword. Okay? Is that clear?
Yeah.
Okay. The next thing to do is the length of a set. Since a set is made up of items, can we find out how many items are actually in a set? Yes, we can do that using our friend here, length function. So you can say how many items are in planet, the set planet. You can run that, length planets, 9 items. SADC, how many items are in SADC? You run length SADC, 15 items. How many items are in the set COMESA? 20. Okay. Then here, changing items in a set. This is not allowed. And it's not possible. Okay? The reason why you can't change an item in a set is because, one, there is no index. What position are you going to use to change? So if there is no index, we can't change things. Okay? So once an item has been added to a set, you can't modify the value of that item. However, there are certain things you're allowed to do. You are allowed to add new items to a set, or you are allowed, I think, to remove items from a set. So you can add items to a set, you can remove items to a set, but you cannot modify a value which has been added to a set. Is that clear? You can add new stuff, you can remove things, but you can't modify or you can't change. Are we clear?
Yes.
Okay, so how do we add items to a set? So we're going to start with, how do you add one item to a set? That's the first thing you're going to start with. For you to add one item to a set, you need to use the add method. This add is not a function, it's a method. And we know how methods work. You start with whatever thing, whether it's a list, you start with the name of the list or the name of the tuple, then you put a dot followed by something like this. So in this case, we are going to start with the name of the set we're going to create, then we put a dot, then we say add, then inside the add, we add whatever item it is we want to add. Are we clear?
Yes.
There are two ways of doing functions. One, using a function. Two, using a method. We are using both of them, and I'm showing you how it's done using both of them. So what do we do here? We create a set called fruits here. This set called fruits has got items apple, mango, guava, banana, and cherry. So it has got 1, 2, 3, 4, 5. 5 items. So we create it there. Then we check. We want to convince ourselves if actually we have a set from this thing. There. Python tells us, yeah, we have a set. When you print it, what do we get? This is what we get when you print it. We get mango, faced, banana, guava, apple, cherry. This is completely different from what we have here, what we have in the list, and what we have in the set. The order in which items have been arranged is completely off. Can you see that?
Yes.
So basically, you don't know which item is going to be the last, which one is going to be, which one, like that. You don't. Okay. So how do we add an item to this guy? So we want to add orange to this fruit, this set called fruit. So we say fruit, then dot add, then inside add, that's where you put your orange, like that. So you run that. Then you print fruits. And here is your orange. It has been added somewhere in the middle. You have no control over where the orange is added. It's just added. Whether it's at the beginning or at the end, you have no control over that. Can you see that? Hello?
Yes.
Yeah, we did not specify where the orange was supposed to be added. It just added itself. Okay. Then we also practice with lemon. We want to add the fruit lemon, so we say fruit dot add lemon. We run that. Then we print fruits, and our lemon has been added at the end. The same thing we did. Somehow orange is added in the middle, lemon is added at the end. So this is something about these sets. Okay? Any questions on how to add one item to a set? An existing set. Any questions?
No question.
Brian?
No question.
Okay. Next, we move on to how to add multiple items to a set. If you want to add multiple items to a set, you need to use the update method. The update method. So we print our set fruits there. Now what we want to do is want to add these guys. Want to add avocado, want to add pineapple, want to add berries, want to add strawberries to the set fruits. So for you to add multiple items to a set, these items you're adding, you need to put them in a list. So like as follows. So fruits, then you put a dot here, update, then inside update here, you need to give update a list of items you want to add to the set. Is this clear? You need to give update a list of items you want to add to the set. Like that. Then I print fruits. And this is what I get. I get mango, banana, orange, guava, blueberries, apple, pineapple, cherry, avocado, strawberries, lemon. They've been added all over the place. Is this clear?
Yes, it is.
Okay.
Yes.
Okay, good. The next bit is, so with a set, as much as you're not allowed to access an item, okay, you are allowed, you're not allowed to slice, you are allowed to add an item, or you're allowed to add items to a set. The other thing you're allowed to do is you are allowed to remove items from a set. If there's some item you kind of like don't want from that particular set, you can remove it. And there are three ways of doing that. The first one we're going to look at is by using the remove method. The second one is by using what's known as the discard method. Then the third one is by using the pop method. So let's start with, how do you remove an item from a set using the remove method? So you start here, fruits, then you put a dot, remove, then you give the name of the item you want to remove. You can't give the position because position with sets doesn't exist. There is no index with sets. So the only option you have, if you have to remove something from a set, you have to give the name of the particular item you want to remove. So in this case here, I want to remove the item apple. So fruits.remove, then apple. I run that. Okay, very, very quiet. I don't know whether it has been removed or not, so I check. I want to find out if apple is still in fruits. So I say apple in fruits. False. This tells me apple is not in fruits. You can do another check this way, say apple not in fruits. If you say apple not in fruits, this comes out true. So you've got two ways to confirm if your item has been removed. This you can confirm like this because sometimes your set might be very, very big. So you might not be able to see if that particular item has actually, you might not be actually able to see whether your actual item has been removed or not. So you can check like this, say apple in fruits or apple not in fruits. If you try to remove, so now we know that apple is no longer in fruits, right? We have this confirmation that apple is no longer in fruits. If you try to remove an item which is not in a list using remove, you get an error. If you try to do this, trying to remove something which is not in a list, so in a set, you get an error, and you get this kind of error. It says it's a key error. Apple, it's not there. That's what it's trying to tell you. Is this clear?
Yes.
Okay. Another way to remove an item, so you're removing one item at a time. Another way to remove an item from a set is to use a method called discard. Again, these removing methods, you need to give them the name of the item you want to remove. Okay, so here we want to remove mango from the set fruits. So we say fruits, don't discard, then the item we want to remove is mango. There. Then I check if mango is still in fruits. So mango not in fruits. Is mango not there? Yeah. Mango is no longer in fruits. Here, mango in fruits, false. If you try to remove using discard, if you try to remove something which is not there, you don't get anything. Nothing happens really with discard. You don't get any error to say, like here, I'm trying to remove apple. But remember, we already removed apple, right? If I run discard, nothing happens. It's just quiet. It doesn't tell you anything. Okay? If I try to discard mango, which I've already discarded, I don't get anything. Is that clear? So discard is very quiet. It won't confirm to you to say, this thing you're trying to remove has already been removed. It doesn't. It just quietly kind of assumes as if, okay, fine, it just been removed, but doesn't tell you anything. The third way to remove an item from a set is using the pop method. Now, the thing with pop is that you can't really tell which item has been removed. Okay? You cannot say, like the way we have said here, remove mango, remove apple. You can't do that. It just removes things on its own. It chooses what to remove. So you have no control. Usually you want to assume to say pop on its own is going to remove the last item in your list. But sometimes that doesn't happen. Sometimes it can remove the last item in your set. Sometimes it doesn't, just remove something else. Basically, so when it comes to pop, you have no control over which item is going to
for the
remove.
pop. It just removes what it wishes to remove.
Yes.
But
it will tell you what it has removed.
Oh.
Yeah, it will remember our discard and remove. They just removed things. They didn't say, "Oh, I've removed these things," right? But pop is going to tell you what I've removed. So yeah, this is what I've removed. You've seen, like here, fruits.pop banana is telling you I've removed banana. Did you choose? Did you want banana to be removed? No, it just decided on itself. Say, okay, I'm going to remove the first guy.
Just doesn't like bananas.
No, it just chooses it. I don't know how it works in the background, but that's what it does.
So now, if let's say, for example, it has chosen something that you didn't want to remove.
So you
will you?
Yes.
To put it back using the other methods that we've done, like the add.
Yeah, you can try to do that. You can try to. Yeah, you can add it back.
No pooping.
So it's not very nice because you've got no control over what you're removing. It just chooses what to remove. Then so banana. Then we print our fruits. Okay, so if you check nicely in our fruits, banana is not there. If you again, now this pop, the advantage here is this popped item, this banana, okay, you can save this popped item in a variable. The other things for discard and remove, the things which are being removed cannot be saved in a variable. But pop allows you to remove some item. It's going to choose itself from your set. It gives you an opportunity to save that item in a variable so that you can use it somewhere else. Is that clear? Here. So when you just say pop fruits.pop, you get a value like this. This value, in this case, we got banana. You can store it in a variable called popped item. So we run that. So we pop another value. We don't know exactly what you've popped. Then we print popped item. Okay, it said it pop an orange this time around. So it hates bananas and oranges. Then you can check if, so the popped item has been stored in thing. So you can check if popped item, the value stored in popped item is actually still in fruits or it's not in fruits. So popped item in fruits, false, it has been removed. Popped item not in fruits, true. Is this clear?
Yes, it is.
Yeah, so basically, yeah, that's what sets up to. The other thing you can do with a set is you can make it empty. You can clear everything in a set. You can remove everything, all the contents of a set. Not deleting it, clearing it. Okay, for example, if we look at the set planets, this is what we have now: Saturn, Earth, Pluto, Mars, Venus, Neptune, Mercury, Jupiter, Uranus. Things are arranged in whatever way you want. If you want to empty this set, you have to use a method called clear. So you say planets.clear. If you say planets.clear, it will run. Then after it has run, You want to check how many items are in planets now using the length function. 0 items. So all those items which were in planets have been removed from the list itself. The set itself planet is there, but it doesn't have anything anymore. Is this clear?
Yes.
Rachel?
Yes.
Okay. You can copy a set. You might need to copy a set. And how do you do that? Using the copy method. So here we are. Yeah. I make a copy of fruits. Using the copy method. So I say fruits.copy. The copy I'm going to store as copy fruits, like that. Then I print out fruits. Copy fruits. Here you are. This is what the copy looks like. So it has got berries, guavas, cherry, avocado, strawberries, pineapple, and lemon. I also make a copy of the set Sadiq. So saying Sadiq.copy, then I store in copy Sadiq. Run that. Then I print copy Sadiq. This is what I get. Zambia, Namibia, Mozambique, and stuff like that. I also make a copy of Comesa. Comesa.copy, then copy Comesa. What happened? I'm sure I've got a set called Comesa. So let's give it time and see. Is it clear how to make a copy?
Yes.
Okay, yeah, it has succeeded. So maybe it had some internet issue stuff. Then you print copy Comesa. Okay. Oh, so auto saving failed. Alright. So must have been some internet business there, working with the internet. The next thing is you can delete a set. The same way you can delete a list and a tuple, you can use the delete function to delete a set. So we have got this fruit set. We print it. You can use the delete function to delete it. Then I delete it using delete function. Delete this guy. Then I give it the name of the set I want to delete. Delete goes about its business quietly. I try to print fruits. There. Python brings out the red pen, say fruits no longer exists. The reason why fruits no longer exist, the set fruits no longer exists, is because I've just deleted it. Here. Is that clear?
Yes, it is.
So you can use that. Okay. Remember we made a copy of fruits, right? If you say you try to print copy fruits exists. You see this? Copy fruits exists. So basically, a copy of a set is actually a different item. If you delete the one you copied it from, the copy remains. You see that?
Yes.
Yeah, the copy remains. Okay. Now, these are sets, like mathematical sets, okay? You can try to find out, you can do some mathematical operations on these sets, apart from what you have done. For example, you can try to find out if two sets are disjointed, whether these two sets have got no intersection or not. Okay? If they don't have an intersection, then you can disjoint, this function, this method called is disjoint is going to say true. If there is an intersection, then it's going to tell you false. Okay, for example, here the set Sadiq and the set Comesa, are they disjointed? Do they have any common elements? Is disjointed? The answer is false. The reason is because Sadiq has got a country like Zambia, Comesa also has got a country like Zambia. So there is an intersection between Sadiq and Comesa. If you check between Comesa and disjoint between Comesa and Sadiq, again it tells you false, because there is a country. There are some countries which are members of Comesa and there are some countries which are members of SADC. Is that clear? So you can quickly see, you can quickly check if they are countries or their values or items which are in a particular site and also in the other site. If there are no values which are in this set and the other set, then is disjoint is going to give you true. For example, the set of Zambian provinces and the set of SADC countries, we know that our provinces have got Muchinga, Southern, all these guys, compared to the set of SADC countries, there is no intersection. There is no item which belongs to provinces which is also a member of SADC. So in this case, when you say province dot is disjoint SADC, we get a true. Again, province then dot is disjoint Comesa, we get a true in this case. Is that clear how this works? There is disjoint. Is it clear?
Yes.
It gives you a true value if there is no item which exists in both sets. If there's something which exists in both sets, then it's going to give you a false. The other mathematical operation, set operation, you can carry out is a subset. If you have got two sets, you want to find out if this particular set is a subset of the other set. For example, I want to find out if SADC is a subset of Comesa. Every item in SADC, all the elements in SADC, are they also found in Comesa? Kind of, as I think the answer is no. Comesa subset of SADC? No. So I decided to create a set without a name. This set here, as you can see, it has got Zambia, it has got Angola, it has got Botswana, it has got Namibia. Which is this set? This one. Then I tried to see if this set is a subset of SADC. What do I get? Do each of these elements, are they found in SADC? The answer is true. Zambia is found in SADC, Angola is found in SADC, Botswana is found in SADC, Namibia is found in SADC. So that's how you check for a subset. I also tried to create another set, this one. Zambia, a set of Zambia, Uganda, Madagascar, Rwanda, Kenya. Then I tried to check if these are a subset of Comesa. Are each and every these items, are they found in Comesa? These elements, Zambia, Uganda, Madagascar, Rwanda, Kenya, are they all found in Comesa? If I run that, yes, that's what I get. So we get a true there. The opposite of subset is a superset. Okay? The opposite of subset is when you do a subset is a smaller set. So you're trying to say, are all these items in this small set found in the big set? That's what you're doing, a subset. The opposite is, if you have got a bigger set, you're asking, does this big set contain the items which are found in a smaller set? Then you are doing a superset. Is that clear?
Yes.
Okay. So I do a reverse. SADC is superset of this set. Basically, I'm saying SADC contains this set, and when I run that, I get it true. Again, here, say COMESA is superset of this particular set, which was a subset. True. I check if COMESA is a superset of SADC. COMESA a superset of SADC? No. Not every item in SADC is contained in COMESA. Some items in SADC are in COMESA, but not every item in SADC is in COMESA. Is that clear? So that's why the COMESA is superset of SADC fails. Not every item in SADC is in COMESA. It's found in COMESA. Are we clear? We are now doing sets, mathematical sets.
Yes.
Okay. The next operation, set operation you have to do is an intersection of two sets. It can be an intersection of two or more sets, but you're going to do it only for two sets. Intersection implies the sets of elements which are found in both sets. So for example, here we say COMESA intersection SADC. Which elements are found in which elements? We are saying which elements found in COMESA are also found in SADC. Which items which are found in COMESA are also found in SADC. So we print that. So these are the guys. These guys are found in COMESA, but they're also found in SADC. Zambia, Malawi, Eswatini, DRC, DR Congo, Madagascar, Seychelles, Zimbabwe, Mauritius. You can also do the same. SADC intersection COMESA. You're saying which countries are found in SADC are also found in COMESA. The answer should be the same as the one before. You have Zambia, Malawi, Eswatini, Congo, DR, Madagascar, Seychelles, Zimbabwe, Mauritius. So the intersection, whether you look at it from this side, from SADC side, or from the COMESA side, it is the same. Okay. Okay. There is this other thing called intersection update. It's a method. Now, this method, intersection update, does something quite interesting. Okay. What does it do? It removes items in a set that are not present in the other set. So the items in a particular set which are not present in the other set, they are removed. Okay? Does that make sense? Okay, let's see how it works. Let's see how it works.
Okay.
Yes. I print a copy of COMESA. As you can see, COMESA has got a lot of countries. Okay? COMESA has got a lot of countries. I also print a copy of SADC. This is SADC. Zambia, Namibia, Mozambique, Botswana, Malawi, that and the like. So when we do this intersection update, what intersection update? Excuse me. Just a minute. Hello?
Brian,
Mkwai?
Burishani.
Ngerete bwino. Abaso taito alashala fena SADC nga twacha intersection updates te?
Eh?
Banga twacha intersection updates. Taito alashala fena SADC kweta ma countries aya non.
Kai, what he's saying is that update ilefunya amashan ayashirimu in one of the sets. So like the shit means to alashala fena SADC. No, Leland. So apart from alashala fena SADC, since it is removing so to alashala na SADC
Twala mwana.
Okay, Anam.
Bushe, does it have the same ones all throughout? Because muni mbona mu Congo yala shala.
Guy, what it is that he updates, it is removing items that are not in the other set. So, umumuri komesa, yanga funya mama countries, yonse ashiri musadik. I think that's what he's thinking. So in short, mala shala ke kwati na sadik. That's what he's saying.
Even me, that's what I'm thinking. So I've been a go for somebody of me, I'm on the komesa. Oh yeah.
Nice program.
That's it.
It's a nice thing.
It's interesting. I'm telling you, I've enjoyed it.
Okay, I'm back. I don't know what you enjoyed. Okay,
Huh?
I'm saying I'm back.
Okay.
Okay.
Yeah, so when you do copy comesa dot intersection update SADC, it runs, then you print your copy comesa. Your copy comesa would have changed. Now your copy comesa has got these guys: Zambia, Malawi, Eswatini, Congo DR, Madagascar, Seychelles, Zimbabwe, Mauritius. If you look at these guys, these sites: Zambia, Malawi, Eswatini, Congo DR, Madagascar, Zimbabwe, Seychelles. This is the same, I think, this is the same set as this, the intersection set. So what has happened is that in copy comesa, every item which is not part of the intersection in copy comesa has been removed. Is that clear?
Yes.
It's like you've got a set, then there's an intersection, then you remove every item which is not in that particular set, which is not part of the intersection. You get rid of it. Yeah, that's what that does. Okay. Then next operation is a union of sets, a union of two sets. So if you want to if you want to add your sets so that you create a bigger set, in this case we would SADC, use a union method. Union, say SADC.union comesa. If you do that, this is what you get. So you get a combination SADC and comesa. So you have good countries which belong to, like this one's Mozambique, Botswana. These are SADC countries. But then you've got countries like Burundi, Djibouti. Those are comesa countries. Then you have Angola is a SADC country. Then you've got Comoros is a comesa country. Ethiopia is a comesa country. Uganda is comesa. Kenya is comesa. Congo is comesa. You've got Eritrea is comesa. You even have Libya there is comesa. So basically what you have is a union of the two sets. If you do it the other way, comesa dot union SADC, you get the same thing again. Mozambique, Botswana, DR, Tanzania, Ethiopia, like that. You also get another union thing. So basically that's how you do your union set. Is this clear?
Yes.
Okay.
Clear.
The other one you can do is a difference of sets. The opposite of intersection. In this case, difference method returns a set containing the difference between two or more sets. So if you say SADC difference comesa, then you're going to get a set of countries which are found in SADC but are not found in comesa. That's what you get. You get at least a set of countries like Namibia, Botswana, Mozambique, Lesotho, Tanzania, South Africa, Angola. These are SADC countries, but they are not found in comesa. That's what we mean by difference here. Is that clear? These are the countries, when you do difference update, these are the countries which are thrown out when you're doing a difference update. Somewhere up here, I think here, when I do, sorry, intersection update. When you do intersection update, the countries which are thrown out, these are the ones. Okay? These countries, when you do a difference update, you can save SADC dot difference COMESA. You can save them in this thing here. You can save them in a variable. Say SADC. Maybe you want to use them somewhere. You can save them in a variable. Then you print them. SADC COMESA difference. Here, Namibia, Botswana, Mozambique, Lesotho, Tanzania, South Africa, Angola. You can also work out the difference between COMESA and SADC. Basically, you're talking about the list of COMESA countries which are not members of SADC. So you say COMESA dot difference SADC. So this one is going to give you a set of COMESA countries which are not found in SADC. Kenya, Congo, Sudan, Eritrea, Comoros, Ethiopia, Rwanda, Egypt, Burundi, Uganda, like that. Is this clear?
Yes.
Okay. You can also save this. COMESA dot difference SADC. You can save it in COMESA SADC difference. Then you can print it like that. So those are the countries found in COMESA which are not found in SADC. Are we clear?
Clear.
Okay. This one is the last operation. I think we do the last operation we're going to do on sets. Again, we're targeting our 1 hour. We are already above by 7 minutes. Okay. Difference update removes items in the set, removes the items in this set that are also included in the other set. So basically, difference update removes the intersection items. Okay? Those items in the intersection, it removes them from a particular set. So here, we make a copy of COMESA. I also make a new copy of SADC. Then I say COMESA dot difference update copy SADC. Copies COMESA like that. So it's going to remove the intersection elements from COMESA. So I'm going to remove, I'm going to remain with only, I should remain with only those COMESA countries which are not members of SADC. Is that clear? These.
Yes.
Yeah. Okay. So, this one here. How do I know how to do all this? If you have got a data structure, for example, a set, you can run this command. Some of the things, some of these methods, how do you find out which methods can I use with this particular thing? We are talking about a set here, right? So you say this thing dir, then you give it the name of the data structure you're looking at, then you print. When you do that, you get this. I think this doesn't come out now. Let me remove the print so that you can see properly. I just say dir set, directory set. This doesn't come out quite well, but anyway, you see these guys: add, clear, copy, difference update, discard, intersection update, is disjoint, is subset, is superset, pop, remove. We have looked at union and update. This is how I know by doing this. When I do this, dir set, this is how I know what kind of operations I can carry out with a set. Is that clear?
Yes.
When you say dir, then inside dir there, you put in the name of the object or the name of the structure you're dealing with. That is how I know which items I can do. So if you can list add, for example, here is add, say add, okay, then you want to find out how do I use add. Okay, then you do this, you say help, then inside help, the name, set, then you put a dot, then add. You do that. Then you're going to get a short explanation of what add does. Then say okay, fine, add is a method. Then what does it do? It says adds an element to a set. This has got no effect if the element is already present. The reason why it has got no effect if the element is already present is because a set can only have one element, one item at once. Is that clear? So this is how you find out how a particular method works. Is that clear?
Yes, it is.
There is also, which one? Something we used, remove. We used remove to remove items from a set. How do you find out how to use it? Here, you give it to help set.remove. Then here it's going to, you have remove, then you offered an explanation. It's a method. Then the explanation is remove an item from a set. The item you're trying to remove, it must be a member of the set. If the item is not a member of the set, raise a key error. Is that clear?
Yes.
Yeah, we'll look at this other bit later on in future, but basically I just wanted you to be aware to say, if you have, this works anywhere in Python. If you have got something, then you don't know how to, you have got a structure which has got methods, then you want to find out what kind of methods or what kind of operations you can perform. Then you use this print dir. Then once you have done a print dir, if you want to find out, for example, you've got this, then how do you want an explanation of how to use it, because clearly I might not always be there with you. So you can always get help using Python. Python is always ready to help you. Python has got a function called help. Then this help function, you give it, for example, the item you're looking at is a set, put set.add. If it's a list, you type in lists. If it's a tuple, you type tuple, then dot, the name of whatever method it has printed out. Are we clear?
Yes.
Okay. So we're going to end here today. Now tomorrow, I don't know, but tomorrow's arrangement is going to be suspect because we have I think tomorrow, let's just cancel out.
Okay.
We'll meet on Monday. We have a meeting, a long meeting to discuss examination results. So the meeting is going to be the whole day, and I'm not sure when it's going to end.
All right.
Yeah, so basically tomorrow, let's cancel. We will continue on Monday. We'll continue doing these things because it's online. Okay?
Yes.
Yeah. Brian has got experience with what we did last time. So basically that's going to be the process. Bit by bit, in small chunks. Eventually we're going to cover all the material we need.
Okay.
Yeah. So that when you come for your next residential, at least we should have moved forward.
Oh, okay.
Yeah, we should have moved forward. Okay, so we have come to the end. Unless you've got any questions.
No.
Okay, so tomorrow is cancelled.
Alright.
I'll see you on Monday.
Okay, see you on Monday and have a lovely weekend.
Thank you very
And take
much.
care.
I'm cured now. I've declared myself cured.
We thank God for that.
They didn't call. No, they didn't call me. They haven't called me, so I've just decided to declare myself cured.
No.
That's a nice one.
Alright, thank you.
Okay, cheers, Zamka.